Python offers a rich collection of container data types beyond the basic built-ins like lists, dictionaries, and sets. It also offers a rich collection of specialized container data types, these providing additional functionality that can be particularly useful in a variety of real-world applications, such as log processing, pattern recognition in genomics, and financial data analysis. This lecture delves into these containers, exploring their unique features and practical applications. Let's begin the discussion with named tuples. A named tuple in Python is a subclass of tuple that allows for accessing its elements not just by index, but also by name. This enhances readability and clarity, especially when dealing with a large number of fields. Consider a scenario in the context of genome pattern recognition where you might have a tuple representing a gene with properties like name, function, and location. With named tuples, you can access these properties by name, making the code a lot more understandable and readable. Let's now move on to the double-ended queue, pronounced Dec. It's an ordered collection similar to a list, but optimized for quick appending and popping of items from either end. This is particularly beneficial in scenarios like log processing, where new log entries are continuously added and older ones are processed and removed. Now, unlike lists that have order n performance for inserting and popping items to and from the first index, Deques, or double-ended queues, maintain an order 1 performance for these same operations. Let's now talk about ChainMap. This is a dictionary-like class that can link multiple mappings like dictionaries into a single updatable view. It searches through the mappings in order and allows for efficient reusability of common configurations with overrides. For instance, in stock price anomaly detection, ChainMap can be used to link default algorithm parameters with user-provided parameters, creating a unified view of settings. We'll explore this use case in the hands-on to follow. Counter is a subclass of dictionary tailored for counting hashable objects. It's a natural fit for tasks like tallying words in text data, a common need in data analysis. For example, in genome pattern recognition, counter could be used to count the frequency of various DNA sequences. OrderedDict is a specialized dictionary that remembers the order in which its contents are added. While the standard dictionary in Python 3.7 and later also maintains insertion order, OrderedDict remains useful, especially for its order-sensitive equality checks. In financial analysis, this can be crucial for maintaining the order of transactions, for example, or stock price updates. Then we have defaultdict, which simplifies handling missing keys in dictionaries. By providing a default value for missing keys, it automates what would otherwise require manual assignments. For our streaming log processing use case, for example, this can be helpful to initialize default values for new log entries or categories. The UserDict, UserList, and UserString classes act as wrappers around the basic dictionary, list, and string types, respectively. They're designed for easier subclassing, allowing customization and extension of the basic types functionality. In various data processing tasks, such as modifying default behavior or adding custom methods, these classes provide a convenient starting point. Let's now discuss each of these in the context of a few practical applications. Deques can be used in streaming log processing for efficient log queue management. Then we have defaultdict, which can be useful for initializing default log categories, and counter, which can be useful for statistics like error counts. In the context of genome pattern recognition, named tuples can represent gene information, counter can be used for DNA sequence frequency analysis, and ChainMap for linking genetic research configurations, for example. And in our third use case, stock price anomaly detection, ChainMap, for instance, can be used for combining default and custom algorithm parameters, OrderedDict for maintaining ordered financial data, and counter for frequency analysis of market indicators, for instance. In conclusion, the specialized containers we've discussed in this lecture are only some of many that help extend the capabilities of the basic types available in Python, offering more tools to programmers for writing efficient and readable code. Let's now head over to the hands-on coding session to see all of this in practice. See you there.